torque screwdrivers are important for achieving precise and consistent tightening of screws. They prevent screws from being over-tightened or under-tightened, either of which can cause structural damage or performance issues. The inconvenience and time involved are often cited as reasons for not using torque screwdrivers. However, the long-term benefits and professional standards associated with their use outweigh these short-term drawbacks. If asked in a court of law, explaining why a torque screwdriver was not used would require justification of that decision, despite the known industry standards and potential risks. The explanation would need to demonstrate that the workmanship is not compromised and that the reason for not using the tool was valid. Many helpers may not even know what a torque screwdriver is, which highlights a potential lack of awareness about the tool itself. It is important to note that torque screwdrivers are calibrated tools that require regular maintenance and recalibration to ensure accuracy. It is important to know how to set a torque screwdriver, an important aspect of using it correctly. Firstly, understand the importance of using a torque screwdriver in electrical work. Secondly, explain why it is important to use one. Thirdly, talk about the importance of workmanship. Torque screwdrivers are used to apply a specific amount of torque to a fastener, like a screw, bolt, or nut. This is critical in applications where the tightness of the fastener directly affects the performance, safety, or longevity of the assembly. In electrical work, this is especially crucial because improper torque can lead to loose connections, overheating, and potentially dangerous situations like electrical fires. Using a torque screwdriver ensures that each fastener is tightened to the manufacturer's specified torque value. When a fastener is under-tightened, it may not provide sufficient clamping force. This can lead to several problems. Firstly, loose connections. In electrical connections, a loose screw can result in a high-resistance joint. This resistance generates heat, which can degrade the insulation, oxidize the metal, and eventually lead to a complete failure of the connection. Secondly, vibration loosening. In environments with vibration, an under-tightened fastener is more likely to loosen over time. This can cause components to detach or malfunction, posing a safety risk. Thirdly, inaccurate readings. In sensitive electronic equipment, loose connections can cause erratic readings or malfunctions due to inconsistent electrical contact. Over-tightening a fastener can also cause significant problems. Firstly, stripped threads. Applying too much torque can strip the threads of the screw or the receiving hole. This renders the connection useless and requires repair or replacement. Secondly, material damage. Over-tightening can deform or damage the components being fastened. This is particularly problematic with delicate electronic components or enclosures made of brittle materials. Thirdly, fastener failure. Excessive torque can cause the fastener itself to break or stretch beyond its yield point, leading to a loss of clamping force and potential failure. Torque screwdrivers come in various types, each suited for different applications. Firstly, manual torque screwdrivers. These are the most common type and are adjusted to a specific torque value using a scale or dial. The user applies force until the screwdriver reaches the set torque, at which point it will either click or slip to prevent over-tightening. Secondly, digital torque screwdrivers. These screwdrivers use electronic sensors to measure the applied torque and display it on a digital screen. They often have programmable settings and can store torque data for quality control purposes. Thirdly, preset torque screwdrivers. These are designed for repetitive tasks where the same torque value is required each time. They are preset to a specific torque and cannot be adjusted by the user. They are often used in mass production environments. To use a torque screwdriver effectively, follow these steps. Firstly, select the correct screwdriver. Choose a torque screwdriver that is appropriate for the size and type of fastener you are using. Ensure that the torque range of the screwdriver matches the specified torque value for the fastener. Secondly, set the torque value. Adjust the torque screwdriver to the specified torque value according to the manufacturer's instructions. This usually involves turning a dial or adjusting a setting on a digital display. Thirdly, position the screwdriver. Place the screwdriver bit firmly into the head of the screw. Apply steady pressure to keep the bit engaged and prevent slippage. Fourthly, tighten the fastener. Apply force to the screwdriver in a smooth and controlled manner. Continue tightening until the screwdriver clicks or slips, indicating that the set torque has been reached. Avoid applying excessive force after the torque limit is reached. Fifthly, verify the torque. For critical applications, it may be necessary to verify the applied torque using a separate torque tester or auditing tool. This ensures that the fastener has been tightened to the correct specification. Torque screwdrivers are used in various electrical applications. Firstly, electrical panels. Torque screwdrivers are used to tighten the terminal screws in electrical panels and circuit breakers. Proper torque ensures a secure connection and prevents overheating. Secondly, control panels. In control panels and industrial equipment, torque screwdrivers are used to tighten the screws on terminal blocks, relays, and other components. This ensures reliable operation and prevents malfunctions. Thirdly, electronic devices. Torque screwdrivers are used in the assembly of electronic devices such as computers, smartphones, and circuit boards. They ensure that the components are securely mounted without damaging the delicate circuitry. Fourthly, aviation and aerospace. In the aviation and aerospace industries, torque screwdrivers are used to tighten fasteners on critical components such as wiring harnesses, connectors, and avionics equipment. This ensures the safety and reliability of the aircraft. Calibration is essential for maintaining the accuracy of torque screwdrivers. A calibrated torque screwdriver ensures that the applied torque is within the specified tolerance. This is critical for maintaining the integrity of electrical connections and preventing failures. Torque screwdrivers should be calibrated regularly, typically every 6 to 12 months, or more frequently if they are used extensively. Calibration should be performed by a qualified calibration laboratory using calibrated torque standards. When selecting a torque screwdriver, consider the following factors. Firstly, torque range. Choose a torque screwdriver with a torque range that matches the specific applications. Consider the minimum and maximum torque values required for the fasteners you will be tightening. Secondly, accuracy. Look for a torque screwdriver with a high degree of accuracy. The accuracy of the screwdriver should be specified by the manufacturer and traceable to national standards. Thirdly, ergonomics. Choose a torque screwdriver with a comfortable grip and ergonomic design. This will reduce fatigue and improve productivity, especially when tightening a large number of fasteners. Fourthly, durability. Look for a torque screwdriver that is made of high-quality materials and designed to withstand the rigors of daily use. A durable screwdriver will provide years of reliable service. Fifthly, features. Consider any additional features that may be useful for your applications, such as digital displays, programmable settings, and data logging capabilities. The legal implications of not using a torque screwdriver can be significant, especially in cases where improper torque leads to failures or safety incidents. Firstly, liability. If a failure occurs due to improper torque, the electrician or contractor may be held liable for damages, injuries, or losses. This can result in costly lawsuits and damage to the company's reputation. Secondly, code compliance. Electrical codes and standards often specify torque requirements for electrical connections. Failure to comply with these requirements can result in fines, penalties, or even the suspension of licenses. Thirdly, insurance claims. Insurance companies may deny claims if it is determined that a failure was caused by improper torque. This can leave the electrician or contractor responsible for covering the costs of repairs and damages. To mitigate the legal risks associated with torque, it is important to implement a comprehensive torque control program. Firstly, training. Provide training to all electricians and technicians on the proper use of torque screwdrivers and the importance of torque control. This should include hands-on training and written materials. Secondly, procedures. Develop written procedures for torquing fasteners. These procedures should specify the torque values, the tools to be used, and the steps to be followed. Thirdly, documentation. Maintain records of all torquing activities, including the date, time, location, and torque values. This documentation can be used to demonstrate compliance with codes and standards. Fourthly, auditing. Conduct regular audits of torquing activities to ensure that procedures are being followed and that torque screwdrivers are properly calibrated. The importance of workmanship cannot be overstated. Workmanship refers to the quality of the work performed and the attention to detail that is given to each task. Good workmanship is essential for ensuring the safety, reliability, and longevity of electrical installations. Using a torque screwdriver is just one aspect of good workmanship, but it is an important one. It demonstrates a commitment to quality and a willingness to follow best practices. In addition to using torque screwdrivers, there are several other steps that electricians can take to improve their workmanship. Firstly, planning. Plan each task carefully before beginning work. This includes reviewing the drawings, specifications, and codes, and identifying any potential hazards or challenges. Secondly, preparation. Prepare the work area by clearing away any obstructions, providing adequate lighting, and ensuring that all necessary tools and materials are on hand. Thirdly, execution. Perform each task with care and attention to detail. This includes making clean and accurate cuts, using proper wiring techniques, and ensuring that all connections are secure. Fourthly, inspection. Inspect each task after it is completed to ensure that it meets the required standards. This includes checking for loose connections, damaged components, and other defects. Fifthly, documentation. Document all work that is performed, including the date, time, location, and materials used. This documentation can be used to track progress, identify problems, and ensure that the work is completed to the required standards. In conclusion, torque screwdrivers are essential tools for electrical work. They ensure that fasteners are tightened to the correct torque, preventing loose connections, overheating, and other problems. Using a torque screwdriver is just one aspect of good workmanship, but it is an important one. By following best practices and paying attention to detail, electricians can improve their workmanship and ensure the safety, reliability, and longevity of electrical installations.